Imagine a place where the laws of nature don't just bend, they shatter. Imagine an object so dense, so powerful, and so hungry that it can swallow light itself. For decades, science fiction has painted them as the ultimate villains of the cosmos dark. Bottomless pits that roam the universe like predatory beasts, devouring everything in their path. We call them black holes, but as our understanding of the universe has evolved, a new and startling picture is beginning to emerge. We are starting to realize that these monsters might not be the villains we thought they were. In fact, without them, you and I might not exist. Today we are going to dive into the heart of darkness. We are going to explore the terrifying power of black holes and ask the ultimate question: are they merely cosmic monsters, or are they the secret architects that built our universe? To understand the monster, we must first understand its birth. A black hole isn't born from nothing. It is born from the death of the most magnificent objects in the sky, massive stars. Imagine a star 20 times the size of our sun. For millions of years, it lives in a delicate balance. In its core, gravity is trying to crush the star inward, while nuclear fusion is pushing outward with the force of billions of atomic bombs. But eventually, the fuel runs out, the fire dies. In a fraction of a second, gravity wins. The star collapses in on itself with such violence that it creates a supernova, one of the brightest explosions in the universe. But if the remaining core is heavy enough, the collapse doesn't stop. It keeps crushing down, smaller and smaller, past the size of the Earth, past the size of a city, past the size of a grain of sand, until it reaches a point of infinite density. This is the singularity. Around this point, a region of space is created where gravity is so strong that nothing, not even light at 186,000 miles per second, can escape. This boundary is the event horizon, the point of no return. This is where the monster persona comes from. If you were to fall toward a black hole, you would experience a nightmare of physics called spaghettification, because the gravity at your feet would be so much stronger than the gravity at your head. Your body would be stretched out like a long, thin strand of noodles. You would be ripped apart at the atomic level before you even touched the event horizon. To an outside observer, because of the way gravity warps time, you would appear to slow down and freeze at the edge, turning redder and redder until you faded away into the dark. But for you, the end would be swift and terrifying. But black holes aren't just invisible vacuum cleaners. When they feed, they become the brightest objects in the entire universe. As gas, dust, and even entire stars are pulled toward the event horizon, they don't fall straight in. They swirl around like water draining out of a bathtub, creating what we call an accretion disk. In this disk, friction and gravity heat the gas to millions of degrees. It glows with a ferocity that can outshine entire galaxies. These are quasars. From the poles of these spinning monsters, beams of pure energy and matter called relativistic jets shoot out across the cosmos at nearly the speed of light. These jets are so powerful they can punch through the fabric of a galaxy and travel for hundreds of thousands of light years. When we see this, the raw, unbridled destruction, it's easy to see why we view them as monsters. They are the ultimate apex predators of the vacuum. But now let's flip the script. Let's look at the architect. For a long time, we thought black holes were rare. We thought they were just oddities scattered here and there. But then we looked at the center of our own galaxy, the Milky Way. We watched the stars at the very heart of our city dancing around an invisible point at millions of miles per hour. We realized there was something there, something 4 million times more massive than our sun, packed into a tiny space. This is Sagittarius A*, A star. And we soon discovered that almost every large galaxy in the universe has a supermassive black hole at its heart. This changed everything. It turns out that the relationship between a galaxy and its central black hole is not one of predator and prey. It is a partnership. Astronomers have found a strange correlation. The mass of a galaxy's central bulge is always proportional to the mass of its black hole. This isn't a coincidence. It means they grew up together. This is the feedback loop. Remember those violent jets we talked about? As a black hole feeds, its jets and radiation push gas and dust out of the center of the galaxy. This sounds destructive, but it's actually a form of regulation. If a galaxy forms stars too quickly, it will burn out and die. The black hole acts like a cosmic thermostat. By blowing away excess gas, it prevents the galaxy from getting too crowded. It regulates star formation, ensuring that the galaxy grows at a steady, healthy pace over billions of years. Without the supermassive black hole at the center, galaxies might never have formed their beautiful spiral shapes. They might have stayed as chaotic, disorganized blobs of gas. The black hole provides the gravitational anchor and the energy rhythm that allows a galaxy to mature. In a very real sense, Sagittarius A* is the reason the Milky Way exists in its current form. It is the reason our sun had a stable neighborhood to be born in. It is the reason you are here today. But the mystery goes even deeper. Black holes aren't just architects of galaxies. They might be the architects of the very laws of physics. One of the greatest minds in history, Stephen Hawking, proposed that black holes aren't completely black. Through a process now called Hawking radiation, they slowly leak energy back into space. Over trillions upon trillions of years, a black hole will eventually evaporate and disappear. This creates a massive problem for science called the information paradox. In quantum mechanics, information can never be destroyed. But if you throw a book into a black hole and the black hole eventually disappears, where did the information in that book go? Is it lost forever? Or is it encoded on the surface of the event horizon like a hologram? Some physicists believe the latter. They suggest that our entire 3D universe might actually be a projection of information stored on a 2D surface at the edge of the universe, a concept called the holographic principle. If this is true, black holes are the keys to understanding the very fabric of our reality. They are the laboratories where gravity and quantum mechanics finally meet the two great theories of science that usually refuse to talk to each other. In the last few years, our journey with black holes has taken a giant leap forward. In 2019, the Event Horizon Telescope gave us something we thought was impossible. The first real photograph of a black hole shadow in the galaxy M87. We saw the glowing orange ring of fire surrounding the darkness. Then we saw our own Sagittarius A*. These aren't just mathematical equations anymore. They are real physical places. And now the James Webb Space Telescope is looking back to the very beginning of time. It is finding supermassive black holes in the early universe that are much bigger than they should be. It's as if they were there at the very start, acting as seeds for the very first galaxies. This reinforces the idea that black holes aren't the end of the story. They are the beginning. They are the gravity wells that gathered the first clouds of hydrogen, sparked the first stars, and built the first cosmic structures. So, are they monsters? Yes, they are terrifying. They represent the ultimate end of time and space. They can rip stars apart and swallow life, but are they architects? Absolutely. They are the foundation stones of the universe. They are the engines of galactic evolution and the regulators of cosmic growth. The black hole is the ultimate paradox. It is a place where death and birth happen at the same time. It is a graveyard for matter, but a cradle for galaxies. It represents the limit of human knowledge, but also the greatest opportunity for a theory of everything. When we look at a black hole, we are looking at the limits of our own existence. We are looking at a place where the now becomes the forever. It humbles us, reminding us that we live in a universe that is far more complex and far more powerful than our daily lives suggest. But it also inspires us. We are a species of tiny, fragile creatures on a small, rocky planet, yet we have managed to understand the heart of a singularity millions of light years away. Think about that. The monster is out there in the dark, but we have brought it into the light of our understanding. As we continue to peer into the shadows of these giants, we are really searching for our own origins. We are looking for the rules of the game. Every time we measure the spin of a black hole or capture the light of a distant quasar, we are adding a piece to the puzzle of how the universe was built. The story of black holes is the story of the universe itself. It is a story of extreme forces, incredible beauty, and the eternal struggle between gravity and light. Whether they are tearing things down or building them up, black holes are the masters of the cosmos. Thank you for joining me on this exploration of the most mysterious objects in existence. This is video number 40 in our journey through the infinite, and I couldn't be more excited about where we are headed next. If you found this deep dive into black holes as fascinating as I did, please hit that like button and subscribe to the channel. Your support allows us to keep pushing the boundaries of what we can explore together. And now, I want to hear from you. Do you think of black holes as more of a monster or an architect? Does the idea of spaghettification keep you up at night? Or are you more amazed by the idea of a holographic universe? Let's talk about it in the comments below. I try to reply to as many as I can, and I always love reading your theories. The universe is full of darkness, but it's our curiosity that provides the light. Keep asking the big questions, keep exploring the unknown, and as always, keep looking up. I'll see you in the next video as we continue to uncover the secrets of the stars. Safe travels, everyone.